Welcome to datascience.show, the podcast where data science meets executive leadership. We talk with top AI and analytics thought leaders about turning data into real business impact. If you're a C-level leader or data expert shaping the future, you're in the right place.
2 months into production, a fraud model started flagging transactions that never existed. Again had invented a pattern, and the business felt it in chargebacks and annoyed customers. That hit the bottom line and trust. Today, we talk about how to prevent that story from being yours.
I'm your host, Mirko Peters. We explore how data science and AI drive real business impact, straight from the leaders making it happen. In the next 20-25 minutes, I'll give you a practical executive playbook for synthetic data, when it makes sense, how to measure it, and 3 decisions you can make this quarter.
Let me set the scene. Imagine a head of data at a regulated company, payments, healthcare, or telecom, facing 3 problems: limited labeled data, strict privacy rules, and a need for edge case coverage. Synthetic data promises a shortcut. It can be that shortcut, but only if you treat it like an operational capability, not a magic button.
Quick background on the kind of leader I'm channeling today. Someone who's run synthetic pilots at scale, bridged legal and engineering, and learned the hard lessons when pilots graduated to production. They look for reproducibility, measurable lift, and auditable provenance, because those are the things that survive compliance reviews and board questions.
Start with a clear objective. Are you trying to reduce privacy risk, lower labeling cost, or increase coverage of rare events? Those goals lead to different trade-offs. Privacy-first programs focus on provable non-identifiability and audit trails. Utility-first programs prioritize downstream model performance. Coverage programs want targeted conditional sampling. One objective per pilot keeps evaluation honest.
Let's break down approaches. First, rule-based simulators. Think domain-specific engines that generate realistic flows under explicit rules. They're explainable and auditable, but building broad realism is expensive.
Second, generative models, GANs, diffusion, large conditional generators. They can produce strikingly realistic outputs, but watch for memorization and invisible artifacts. A realistic image that never occurs in production is dangerous because models will learn to exploit it.
Third, conditional samplers and augmentation layered on real data. These often give the best practical trade-off. You preserve real structure while stretching coverage where you need it.
When evaluating any approach, ask 2 executive questions. Can the team show downstream equivalence, not just high-fidelity samples, but real model performance? And can they provide full provenance and reproducibility for auditors? If either is missing, treat the work as experimental.
About metrics. Fidelity alone is a vanity metric. The metrics that matter are threefold: downstream utility, privacy risk, and operational cost. Downstream utility means training your target model on synthetic data and evaluating on real holdout sets for accuracy and fairness. Privacy risk includes membership inference and attribute disclosure tests. Operational cost covers compute, labeling, and monitoring.
A practical KPI example. Require a synthetic data set to achieve within X points of real data performance on your primary metric. For example, no more than a 2% drop in AUC, or a maximum Y% increase in false positive rate. Replace X and Y with your business tolerances and document them in the pilot charter.
One failure mode I keep seeing. Teams fall in love with neat synthetic records. They look great in a dashboard, so they ship the model. Then reality hits. I've seen teams blinded by those records and learn the hard way when production traffic does not match synthetic quirks. Prevent that by requiring a golden path validation. Generate synthetic training data, train the model, then validate on a withheld real production set and report degradation by cohort. If rare cohort performance diverges, iterate on the generator before production rollout.
Integration is where pilots die. Treat generator artifacts like code. Version them, store seeds and input snapshots, embed lineage metadata, and include generator tests in CI. Canary synthetic data updates the same way you canary model changes.
Small blast radius, measurable rollback.
Vendor versus build. Vendors accelerate pilots, but procurement should demand exportability, the ability to retrain or reproduce the generator from defined inputs, and contractual rights to raw intermediates. For critical workloads, plan a hybrid. Vendor speed early, internalize core reproducibility later. Here are 2 concrete anonymized examples. Example 1. A payments team used conditional synthetic transactions to expand fraud coverage, targeting rare fraud vectors. In their holdout tests, they reported an X% reduction in false negatives versus baseline. Insert pilot number. Crucially, they required real holdout validation before deployment.
Example 2. A healthcare analytics group used a rule-based simulator for imaging edge cases. The simulator delivered explainable artifacts and passed regulatory review because every synthetic image had a provenance record and a reproducibility hash. They still kept a real data calibration gate for clinician review.
On governance, require metadata for every synthetic dataset, generator version, input snapshot hash, conditional parameters, and a changelog. Legal and privacy should be able to answer, why does this record exist? How was it produced? Who approved it? If you can't answer those questions, you're building a black box.
Budget realistically. Synthetic costs show up in compute for large generative models, human labeling for conditional targets, and ongoing validation. Frame vendor SOWs in cost per usable sample and time to value, and budget 15 to 25% of initial savings back into monitoring and audit tooling.
Leadership decisions matter. Assign a synthetic data owner, a single accountable role that coordinates engineering, product, privacy, and legal. That owner tracks KPIs, downstream model lift, privacy risk reduction, and generator drift metrics. Accountability prevents finger-pointing when surprises occur.
Looking forward, plan for 3 durable realities. 1. Artifact drift. Generators age as real distributions change. 2. Regulatory focus. Expect demands for provenance and fairness testing. 3. Emergent standards. Industry reporting will standardize synthetic data disclosures. Build processes, not one-off pilots.
A practical 12 to 24-month roadmap. Quarter 1. Pick a high-impact use case and run a vendor pilot with clear success criteria and a real holdout. Quarter 2. Validate, harden MLOps integration, add lineage and CI. Months 9 to 12, internalize reproducibility for critical paths. Keep specialized vendor services where they accelerate time to value.
3 things to do this quarter. 1. Mandate downstream validation on real holdouts before any synthetic dataset reaches production. 2. Add provenance and exportability clauses to vendor contracts. 3. Assign a synthetic data owner with KPIs tied to model performance and privacy risk reduction. These will materially reduce surprise and increase trust.
To wrap up, synthetic data is powerful, but not magical. The value comes from discipline, reproducibility, rigorous validation, cross-functional governance, and clear business objectives. Connect synthetic capabilities directly to outcomes and treat them like any other critical operational system.
That's the difference between models and value. If you found this episode useful, subscribe and share it with your network. And let's connect on LinkedIn. I'm Mirko Peters. We'll be back with more conversations on how data science and AI create real business impact. Until next time.
Thanks for listening to datascience.show. If you found value in this episode, subscribe, share it with your network, and join us next time as we explore how data science drives smarter decisions and better business outcomes.